considering applications in mathematics, it's very common to have equations that relate several different pieces or several variables. And it could be that we want to focus on one variable in particular. So if I say to solve an equation for a variable, for a given variable, then that means that I want that variable isolated on a side by itself. So far we've been solving for x or solving for y. And so at the end of the equation, or at the end of our calculations, we need x equals something. Alright, so here's a few examples, and I'm going to solve some of these equations for a particular variable. So in geometry, you have a whole lot of different kind of geometric equations, one of them being the volume of a cylinder, for example, where v, the volume, is pi r squared, r being the radius, times height h. Or if you're dealing with finance, you could be calculating simple interest, where simple interest is I, and that's p, the principal, times the rate and the time. Or you could have a temperature conversion, which is very common, where we have temperature in Celsius is 5/9 Fahrenheit minus 32. Alright, so let's look at our first example. So here I'm considering the volume of a cylinder, and what I want to solve for, let's solve for h. Okay, so the principles of linear equations work just as well here as they did when we have x's involved. So what I'm doing now is I'm treating v and I'm treating r squared and pi all basically like constants. And so h is the variable I'm solving for. So you can imagine if I had something like this, if I had a equals bx and I said solve for x, or if you want to get even more explicit than that, let's say something like this, 10 equals 6x, what would you do? You just divide both sides by 6 to get x by itself. The same is going to apply here for volume. Okay, I'm going to say that I divide both sides by pi r squared, and when I do that, I'm left with h on the right hand side of my equation. So there it is. In this equation, h is volume over pi r squared. And there's my answer. So to pull an example out of the business world, here I have the simple interest formula again. I equals PRT, P being principal, R being rate, T being time, I being the interest accumulated. So I could solve here for any of these. How about I solve for P? So I'm solving for the principal. Okay, so again, just like the previous one, this is a linear equation with P. And so all I need to do is divide both sides by the thing being multiplied by P, which is RT. So there it is. In one step, I have P equals interest over rate times time. And that's how much I can find I initially invested if I know how much interest was accumulated and if I know the rate and time. Alright, let me show you another example. So here's something we might see very commonly in a physical situation. I have conversion of temperature from Celsius to Fahrenheit. So if they give me the temperature in Fahrenheit, I can quickly calculate what the temperature would be in Celsius. But what if I want to flip it around? They give me the temperature in Celsius and I want to figure out in Fahrenheit. Okay, so this is again a linear equation and I want to solve for f here. So to do that, first I need to divide both sides by 5/9. Now remember, dividing by 5/9 is the same as multiplying by the reciprocal. Dividing by a fraction is the same as multiplying by its reciprocal. So I'm actually multiplying both sides of the equation by 9/5. So I have 9/5 c equals f minus 32. So then to get the f by itself, all I have to do is add 32 to both sides. So there it is. F is 9/5 temperature in Celsius plus 32. And that's how I can calculate degrees in Fahrenheit, or convert Celsius to Fahrenheit. Okay, now these are some basic examples, but I wanted to just illustrate that the principles of solving equations can help you outside of just solving for x. They can help us convert formulas to be more satisfactory. If you have a good understanding of this, it'll help you in your finance classes and business statistics classes, calculus, physics, chemistry. These principles help across the board. If you have any questions, I'd be glad to help, and thanks for watching.